Welcome back, and here we continue Module 3, Topic 2, Lesson 3. We're in Activity 1, starting on page 425. Our habits of mind. We need to reason abstractly and quantitatively. Remember, that's with numbers. Construct viable arguments and critique the reasoning of others. Viable means it's possible. Just as with addition equations, solving multiplication equations involves determining the value for the variable that makes the statement true. Consider the multiplication equation 2x equals 6. The equation states that for some value of x, the expression 2x is equal to 6. And it shows us that here on this double number line, we actually already had this exact equation. I think I had an n in the last video on the getting started. And now they just have an x, but it's still the same thing. You can decompose the distance of 2x into two equal parts to determine the location of x. The expression 1x, or just x, is halfway between 0 and 2x. And they have you doing this on Mathia, so they'll put a 2x here. And we know that half of 2 is 1, so 1, and there is a 0 here. I don't like that they don't put a 0 there. I think some of you need to see that it's both 0 on each of these. Halfway between 0 and this 2x would be just x. Right? Because 1 is half of 2. So then if we're backing up in an amount that we're dividing it in half, then we need to do half of 6. So 6 divided by 2, or times a half, is 3. Since the expressions are connected as an equation, you also need to locate the point that's halfway between 0 and 6, which is what I just said. By examining the double number line, you can see that x equals 3. So right here, remember that's an equation, x equals 3. Number 1 and 2 here. Use the double number line to decompose the distance of the variable term into equal parts to determine the location of x. Identify and check your solution. So now instead of just 2x, they give us 3x. So if we broke this into 3 equal parts, we would have a 2x here and a 1x, or just x here. So if we're dividing this part into 3 equal parts, remember how we can figure that out. We have 1, 2, 3 ticks between 0 and 12. So 12 divided by 3 gives us 4. So this is going to increase by 4s. So then we have 3x equals 12. Well, what do we have for x? So it tells us x equals 4. So our x equals 4. So essentially what we did, I'm going to add kind of an additional step here for us. We divided this group of 12 into 3 even parts, and we divided this 3x into 3 equal parts. And we know that 3 over 3 is 1, leaving us just 1x, and 12 divided by 3 is 4. This is 3 divided by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So x equals 4. Now it wants us to check. So we have 3x equals 12. Substituting our value that we solved as x with the 4 in for x in the original equation. 3 times 4 equals 12. 3 times 4 is in fact 12. So 12 equals 12. Okay, number 2. Okay, so this time they want us to divide it into 7 equal parts, right? So we have the equation 7x equals 63. So if I divided it into 7 equal parts, like that might be a bit hard to draw, right? And I'm not worried that you necessarily do that. If we can go from here, and we know that if we divide 3 by 3, we get to the x. What would we divide this into? How many parts to get to the x? We would divide it into 7 equal parts. So if I divided it into 7 equal parts, this would be the first one. This would be the 1x. So if I divide the 63 into 7 equal parts, assuming I could accurately draw 7 equal size sections here, this would have the value of, so 63 divided by 7 would give us 9. So 7x equals 63. So what we've essentially done is we divided the top part of our double number line by 7, and we divided then the bottom portion of our double number line also by 7, because what we do to one side we have to do to the other. 7 divided by 7 gives us 1, or just x, equals 63 divided by 7 is 9. So now we need to take our solution, x equals 9, and substitute it back in for the original equation. So we will have 7 x equals 63, 7 substituting 9 in for x equals 63. 7 times 9 is 63, which does in fact equal 63. It checks out. And turning the page, and I guess we're going to see you in the next video for activity 2.